Welcome back to Logic, Language and Information. In this lesson, we'll turn to the task of extracting out the logical form of an argument expressed in natural language, as well as the stronger property of soundness for concrete natural language arguments. When analysing an argument expressed in natural language, the first task is to extract the logical form of the argument by translating it into logic formulas. It is the logical form that must be assessed for validity, so we need to clear away the actual content of the sentences. Consider the following two arguments, one about human free will and another about the financial problems of students. For the first one, the first premise is if genetics determines all our behaviour, then people don't have free choice. And the second premise is people do have free choice. While the conclusion is genetics doesn't determine all of our behaviour. In extracting the logical form, we must notice the repeat occurrences of the basic sentences. The antecedent of the first premise conditional occurs again in the conclusion in negated form. And the consequent of the first premise conditional occurs again in negation opposite form in the second premise of the argument. If we represent the basic sentence, genetic determines all our behaviour, using atomic proposition letter P, and we represent the sentence, people don't have free choice, using atomic proposition letter Q, then we extract the following argument form. First premise, if P then Q. Second premise, not Q. Conclusion, not P. The three dots in a triangle symbol is a standard abbreviation for therefore, to mark the conclusion. You may have seen it before. Notice that we could have extracted a different logical form if we'd made different choices in assigning atomic propositions. We could freely choose to go the other way with the negation opposite by representing the affirmative sentence, people do have free choice, using atomic proposition, say Q, so that the negated sentence, people don't have free choice, then comes out as not Q. In that case, the resulting argument form would be if P then not Q, Q therefore not P. For the second English language argument, the first premise is if living expenses in this city are high, then many students are struggling financially. And the second premise is not many students are struggling financially, while the conclusion is living expenses in this city are not high. The referent to this city for you should be wherever you are living and reading this. Since a great many cities around the world are expensive places to live, the first premise conditional is most likely going to be true wherever you are. Now, in extracting the logical form, we again must notice the repeat occurrences of the basic sentences. For the sentence, living expenses in this city are high, we use the atomic proposition P, and for the sentence, many students are struggling financially, we can use the atomic proposition Q. We then extract the following argument form. First premise is if P then Q, second premise not Q, conclusion not P. An argument form is a list of logic formulas, one of which is designated conclusion and the rest designated as premises. Here, we've left the argument form written in a sort of hybrid logic English to make it a bit easier to read. This form has a Latin name we've mentioned before, modus tollens, and it is also called denying the consequent. Indeed, you can even find it printed on a t-shirt, although with slightly different symbols for negation and conditional. From the premises, if P then Q, together with not Q, conclude not P. The validity of the modus ponens argument form can be explained as follows. Suppose both premises are true, if P then Q and also not Q. With the conditional true but the consequent false, then of the 4 rows of the truth table, we must be in the one and only row where the antecedent is also false, where P is 0 and Q is 0. In this case, the conclusion not P must be true, so we are done, having established validity. So we have 2 concrete arguments that are both valid because they are instances of a valid argument form. Good. However, you might be left thinking that the first argument about human free will is a bit more believable or somehow better than the second argument about the financial problems of students, because the conclusion of the second argument will be false in a great many cities around the world. We'll come back to this difference later in this lesson. Now, as we have already seen, a concrete argument expressed in natural language can be an instance of multiple different argument forms. For example, the 2 arguments on the previous slide are both instances of modus tollens, but are also instances of the similar but distinct form from premises if P then not Q, together with Q, conclude not P. We had some free choice about how to represent sentences by atomic propositions. Those 2 concrete arguments are also instances of other very different argument forms, such as this one, rather strange one, from premises if P then Q and R conclude S. Intuitively, what looks wrong about this argument form is that there is no connection between the premises and the conclusion, because the conclusion is an atomic proposition that does not occur anywhere in the premises. We can sharpen that intuition to demonstrate that the argument form is invalid. With no connection or constraint between the premises and conclusion, we can simply zero in on the one row of the 4-atom 16-row truth table in which P is 1, Q is 1, R is 1, and S is 0. With pattern 1110, it's the 15th row out of 16, and on that row, the conditional if P then Q is true, so both of the premises are true, but the conclusion S is definitely false. It is easy to come up with quite ludicrous concrete arguments that are instances of invalid argument forms. For example, if you are a logician, then you are a geek. Yes, that's plausibly true. Second premise, greenhouse gas levels have increased. Yes, that is demonstrably true and has been true over the last 100 years or more. Conclusion, therefore, the Earth is flat. No, that's definitely false. We can instantiate the atom P with sentence, you are a logician. We can take atom Q to be the sentence, you are a geek. We can take atom R to be the sentence, greenhouse gas levels have increased. And finally, take atom S to be the patently false sentence, the Earth is flat. The moral of this argument is that invalid argument forms are dangerous. Now, time for you to get to do some work, getting practice extracting an argument form from a concrete argument. So, we're going to consider the following argument in black text here. The argument begins, we can conclude that the people will be unhappy. This is because either the government will increase the tax rate or it won't. If it does, the people will have less income to spend and they will be unhappy. If it doesn't, there will be fewer public services and the people will be unhappy. Notice that a concrete argument does not necessarily have the conclusion coming last in sentence order. Look for other clues within the sentence structure. Now, which of the choices, A, B, C or D, is the best argument form for this concrete argument? How did you go? The answer, the best choice of argument form, is C. To see why, we need to make explicit the translating dictionary. We let P represent the sentence, the people will be unhappy. Now this is clearly the conclusion, as indicated by the phrase, we can conclude that, as well as the phrase, this is because, which precedes the other sentences, indicating that they are the premises. That narrowed down the choices to B and C. The best formalisation of the first premise is Q or not Q, taking the atom Q to represent the sentence, the government will increase the tax rate. So then not Q represents the government won't increase the tax rate. Here, choice C is better than choice B because B ignores the negation opposite relationship between the two disjuncts in the first premise. We then let atom S represent the sentence, the people will have less income to spend, and atom T represents the sentence, there will be fewer public services. So the second premise is formalised as if Q, then S and P, and the third premise is formalised as if not Q, then T and P. If you have any remaining questions or queries, look first in the course notes and then go to the discussion boards, and I'll follow the postings there. Let's come back to the argument that is a valid instance of modus tollens regarding the financial problems of students. In spite of the truth-transferring feature of validity for this argument, we detect there is something wrong because the conclusion that living expenses in this city are not high is just plain false in a great many cities around the world, including this one where we're living. And in any city with high cost living expenses, it will also be false that not many students are struggling financially. So then the second premise would also be false. This brings us to the stronger property of soundness for concrete natural language arguments. An argument is sound if and only if it is an instance of a valid argument form, and in addition, all the premises are in fact true. Sound arguments must then have true conclusions, because the truth-transferring feature of validity is combined with some actual truth of premises to transfer, resulting in a true conclusion. So, the falsity in a great many cities around the world of the proposition that not many students are struggling financially means that this instance of modus tollens is valid but not sound. Let's summarise the key concepts. The logical form of an argument is what we get by formalising each of its premises as well as the conclusion. There is some care and delicacy required here, as a concrete argument can be an instance of many different argument forms, and the task is to extract the best logical form. An argument is valid if and only if the conclusion is true whenever the premises are all true. Instances of valid argument forms are always valid arguments. Sound arguments are concrete instances of valid argument forms whose premises are also true. But some instances of invalid argument forms can still be valid arguments. For example, our two sample arguments on the first slide are valid instances of the ludicrous invalid argument form from the premise if P then Q, together with premise R, conclude S. For an argument to be invalid, there has to be at least one situation in which the premises are all true, but the conclusion is false at the same time. This is how we test for validity using truth tables, by checking that there is no row of the truth table in which the premises are all 1 and the conclusion 0. This brings us to the end of this sequence of lessons on the semantics of propositional logic via truth tables. We have seen how to use truth tables to classify propositions according to their logical status, to assess relationships between propositions, and to assess the validity of arguments. We've also seen that truth tables are computationally expensive and that ultimately they are a dumb way of assessing propositional formulas. Working by hand, the practical limit for truth tables is maybe 4 atoms and 16 rows. In the next lessons, I will pass over to Greg Restel, who will begin a new section on the topic of proof trees. The proof tree method provides a smarter alternative to truth tables for assessing the logical status of propositional formulas and of logical relationships between them.